In this video, we're going to take a look at our introduction to factoring, and we're going to explain what that means. And so previously in Unit 4, we looked at polynomials and how to add them and subtract them, which really meant we were combining like terms. And then we also looked at how to multiply them using distributing. Well, to go backwards from multiplying, we also talked about dividing, which is kind of distributing with division, but now we are actually going to look at factoring as a means of separating a number into its factors, or a pair of its factors. And we're going to explain what that means in this video. And so we're going to kind of go through this video, and I'm going to read through some of it, and we'll do some of these examples. This shouldn't take a long time, but I do want to make sure that your volume is turned on, okay? And so it's more important to me that you actually listen to the video. I do want you to copy things down, but just pausing the video and copying down is not a good idea. So we're going to go through this and talk about what factoring means. So in a multiplication problem, the numbers multiplied together are called factors. That's what the word factors means. The answer to a multiplication problem is called the product. Okay, so the multiplication problem, 5 times 4 equals 20. 5 and 4 are the factors, and 20 is the product. So if we reverse this, okay, into 20 equals 5 times 4, what we're doing is we're factoring 20 into 5 and 4. And we've even done that before, we start with 20 instead of 50. 20, we've made factor trees, okay, and we would carry that on, and we've done factor trees like that before. And so we're going to use that idea in today's lesson. So in this lesson, we will factor polynomials. So we're going to look at separating polynomials. So we looked at multiplication problems where we would distribute and get something like this. So the factors would be the 2x and the x plus 4. And then the product is 2x plus 8x. And if we reverse that, we could say that we've factored 2x squared plus 8x into 2x and x plus 4. And so what we're going to do is we're going to practice some of this. So in this multiplication problem, distributing 5 times x and 5 times negative 7 gives us that. The factors are 5 and x minus 7. But the product is 5x minus 35. And so we could do that with a few more examples. So in this case, 3x parentheses x plus 9, those are the two factors. 3x is one factor, x plus 9 is the other factor. And the product ends up being 3x squared plus 27x. Well, what we're going to do today, we're going to skip over examples 3 and 4 here. We're going to look at factoring polynomials, and to do that, we're going to first factor out what we call the greatest common factor, GCF. And you might remember doing that in previous math classes. The greatest common factor is the largest integer, and the highest degree of each of the variables. This is the part that's going to be a little new and confusing. But if I just dealt with numbers, the greatest common factor would be just the largest integer that divides evenly into each of those terms. And so I've kind of gone through an example here. To factor 5x minus 35, we need to recognize that in this polynomial, 5 is the largest integer that can evenly divide into 5x and 35. And you cannot factor out any variable because both terms don't have a variable. All right? So if 5 is our greatest common factor, GCF equals 5, we simply divide each of these by 5, moving it out to the front, kind of like reverse distributing. So we're going to practice some more of these problems. Here's what you're going to do. I want you to turn the page, but before you turn the page, at the bottom corner of this page of notes, I want you to write your birth date. Okay? Just write your birthday in the bottom right corner. If you can hear me, you'll do this. This is one of the ways I'm going to know how you've watched the video. So write your birthday in the bottom right corner of your notes page. Okay, so we're going to practice finding the greatest common factor of polynomials. So first we're just going to practice calculating what the greatest common factor is. So in this first example here, number 5, we were given two terms, 9x and 45, and we want to find the largest integer. Remember, integers are non-decimal numbers. They're numbers that do not have any decimal or fraction parts. The largest integer that we can divide both of these terms by would be 9. I can divide 9 by 9 and 45 by 9. So the largest integer I can divide both of those by is 9. In this problem, 7 and 21 can both be divided by 7, and that is the biggest number to divide both of them by, so greatest common factor is 7 for the numbers. But in this problem, 18 and 12. Now, I can't divide 18 by 12, but they do share a common factor. Okay, I can divide both of these by a 2, because they're both even. But I can go on further. I can divide both of these by a 3. I cannot divide both by 4. I can't divide both by 5. But I can divide both of these by 6. Well, 6 is already half of 12. There are no other factors of 12 beyond 6 other than the number 12. So that is the greatest number I can divide both numbers by. And then lastly, I've got 3 pieces here. There's a 15, a 25, and a 55. Now, I automatically know that if all these numbers end in a 5, I can divide everything by a 5. 15 divided by 5 is 3. 25 divided by 5 is 5. And 55 divided by 5 is 11. So once I divide by 5, that leaves 3, 5, and 11, which don't have any common factors left. So 5 is the greatest integer I can divide all those by. But now we're going to look at the other part of this. The other part of greatest common factor is that we need to find the largest degree of x that can be factored out, meaning the highest power of x. If they do not share a variable, if there is not a variable in both of them, okay, there's nothing I can write. Okay, not applicable, or a little 0 with a line through it like that, or not in A for not applicable. We can't factor anything out as far as terms of x. But in this one, they both have an x. The highest degree that they both share would be an x to the first. Even though this is an x squared, this is 7 times x times x. This is just 21 times x. They only share one of these x's in common. So the greatest common factor of the variable part is just x. Now with these two, there's an x to the 6th and an x to the 3rd. That means they both have at least 3 factors of x. So x to the 3rd is my common factor for the variable. And then lastly, the smallest value of my variable here is a 1, so that's what they have in common. They have an x to the 1st in common. So what we're going to do now is we're going to put that into practice and factor out these greatest common factors, writing what's left. So 5 and 9 are going to help me with 13 here because I'm using the 9x and 45 from both. The greatest common number I can divide both of these by was a 9, and there was no variable in common, so that is my greatest common factor. It gets written in front of your parentheses, and now we're going to undistribute that 9 from both of these and write what's left in parentheses. Since I've taken away the 9, I've divided by 9, 9x divided by 9 is just x. And then I also have to take that 45 and divide by 9. 45 divided by that 9 to cancel it out is 5. So to factor this polynomial by greatest common factor, looks like that. Okay, and we're going to look at number 14 also. Number 14, we've got two terms here like we did earlier, 7x squared and 21x. They share a 7 in common and an x in common. So the greatest common factor is actually 7x. So 7x goes in front of the parentheses. So to factor out the 7x, I'm going to divide both of these by 7x. Well, when I divide this first one by 7x, the only thing left is x. The 7's cancel, and x squared over x to the first is just x. Minus, because it's a minus divided by a positive, 21 divided by 7 is 3, and x divided by x cancels, so minus 3 is the end. To check if you were doing these problems right, simply distribute your answer and see if you get the problem that you started with. So we're going to take a look at those a little bit more in class, but we want to continue on with our video and try and get a little more of the worksheet done. So we're going to move on up. We're going to practice some new problems together, and then I will go through some more in class. So we're going to do number 17. We're going to factor out the greatest common factor from both of these. So what I want you to do is look at these two numbers as two pieces, the number piece and the variable piece. The greatest common factor of the numbers, 6 and 24, the greatest common factor of 6 and 24 is 6. They can both be divided by 6. And then the greatest common factor in terms of their variables, the highest power of the variable we have in common is a 1, x to the first. So out of the x squared and the x, the greatest common factor is the x. Because I can't divide by 2 x's, there's only one there. So whenever I factor out 6x as my greatest common factor, that means I divide each of these by 6x. Okay? The first part, the 6's cancel and we're left with just x, because x squared divided by x is just x. In the second part, the x's cancel and we're left with the quotient of 24 and 6. 24 divided by 6 is 4. And so that is my answer when I am told to factor this into its two factors, a monomial and a binomial. Let's jump over here to number 19. Okay, number 19, we've got two terms here, 5x squared and x. Notice that this has a number in front of it. This one does not. We call that a coefficient. This has a coefficient of 5. The unwritten coefficient here is a 1. The greatest common factor has to be a number other than 1 to be considered. So they don't have a numeric greatest common factor. They don't have a number part of that. The greatest common factor out of these two terms is just that x that they share. So I'm going to put the x in front, and if I divide x from each of those, that just leaves you with 5x at the beginning, plus 1, because x divided by x is 1. So 5x divided by the x just gives me, 5x squared divided by x is just 5x, okay? And x divided by the x common factor gives me just the 1. So this has been an introduction to finding the greatest common factor. And we're going to do a little bit more with this in class, but this is just the first video I wanted to show you to kind of go over what it looks like to factor out greatest common factor. We're going to do some practice with this in class still, but this is your starting point. Okay, like I said, you need to make sure you're listening to the entire video. So I also want you to write your birth date on the bottom corner of the back page also. Then we'll check that when you come to class.